Welcome back to my series on building a web server from scratch in C++. Before we begin today, I want to apologize for some of the background noise. There is construction going on outside, and so you may hear some extraneous noises. So nothing we can really do about that, so let's move on anyway. Last time we created the simple socket object, and this is going to serve as the foundation for all of the sockets we may need in our networking programs. And today we're going to expand on that functionality by creating a binding socket. So if you remember to our previous episode, we created this connect to network function. And this function we set as a virtual function because different kinds of sockets need to do something different here. So if we go back to our example on medium.com, another shout out is due to Mr. Skrew Everything. So great guy. Anyway, if we look at the example of a server that this guy has written, the server uses this bind protocol with the server FD and then this conversion of the address variable and then size of address. Whereas his client implementation uses connect as the function with the same parameters. And so depending on the kind of socket we create, we're going to need to implement something different here. And in order to force the user to do one of these, or even some other one that I don't know about yet, we used this virtual function. So now we have to create a class that inherits from simple socket and will implement this virtual function in its own way. So I'm going to create a new file, and I'm going to call it binding socket. And let's open the header file, and I'm going to open it next to the simplesocket.cpp. And what I want to do is, well, first let's declare our namespace. And let's create the class. And we'll call it binding socket. And it's going to inherit from simple socket. So we're going to need to include that. So let's put that here. Okay, so far so good. And what is the relationship we want between binding socket and simple socket? Well, we want access to all of the same functions. So we're going to go ahead and set it to be a public inheritance relationship. That way we can still access all of these functions. So what we're going to need to do is essentially just define this connect to network function. So this will be public. And we're going to say, well, first we need a constructor. So let's say binding socket. And the user is never going to directly implement simple socket. So all of the parameters that go into the simple socket constructor need to be passed into the binding socket constructor first. So let's see here. Let's do int domain, int service, int protocol, int port, and ulong interface. Now, I'm not sure that that is exactly how we're going to end up doing this in the future. And the reasoning is that it may be that with a binding socket, we can make some reliable predictions about how it will be used. I know that this is going to be used as a server, so maybe I can go ahead and specify the service or the domain for this. For now, I'm going to leave it so that you have to be explicit with what these are going to be, but I may change that in the future. And this constructor is just going to call the constructor for simple socket and pass all of those things along. So when we instantiate an object of binding socket, it is going to automatically instantiate an object of simple socket and just pass in all of our parameters to its parent. So now we need to actually define this connect to network function. And what should we have as the return type here? Int. Okay, so we're going to say int connect to network. So this is going to override that virtual function, and we're going to need to pass it int sock and struct okay. And it seems that we're going to use the getter functions getSock and getAddress to collect those variables from the simple socket class because they are in fact private. So let's swap over to bindingsocket.cpp and let's define our functions. So let's say hde binding socket, and let's make it connect to network. And this is going to be get sock. Is that available? Yeah, get sock is available. And we're going to say get address. Okay. It doesn't like that. Ah, my mistake. I'm trying to actually do it here rather than just define it. Okay, so let's take a look at our binding function. So over in our server example, we pass it the server FD, which is the connection, and then we do a conversion, or we cast our address variable as a pointer to a sock addr struct, and then we send it the size of address. So we can just say, and before we do that, let me check. Okay, connection is what the result of this is. But we do that as, I may not be being too clear here. Just give me 1 second while I look at this. Okay, yes, you can see connection is set to be whatever connect to network has as its result. And we also call connect to network in this constructor for simple socket. So all we need to do here is say return, and then we'll just specify this binding function. Bind, and we're going to pass it sock. We're going to pass it this casting of struct addr as a pointer, and then we'll give it the dereferencing parameter for address, and then we'll say size of address. Okay. What's the problem here? Ah, yes, my mistake. We need to specify int. Okay, so now we have actually implemented a version of this connect to network function. And in fact, I'm not sure what else we need on this binding socket. So at this point, we might consider making additional types of sockets as children of our simple socket. So we could make one for this client side where they use, where is it? Connect. They use this connect function. So I could go ahead and create this connecting socket that just does exactly the same thing. It just has this constructor that passes information along, and then it defines our connect to network function so that it will, actually, I'm starting to think, I think we're going to have a problem here. So simple socket, in simple socket, do you see what I did here? I connect to network in the parent function. And this was a mistake now that I think about it. And the problem is that when it calls this connect to network function, it's going to call it from the parent class. So I am referencing it within the parent class's constructor, and so it is calling that function in the parent class as well. So I need to remove that here and change it so that in the binding sockets constructor, that's where this is called. Okay, so I'm glad I caught that. So let's say HDE. I know I totally changed my train of thought there. Just let me get this going and we'll come back to what I was actually trying to say. Binding socket, and we need to pass it, let's see. Okay, it's just reacting to my thing, okay. We'll pass int domain, int service, int protocol, int port, u long interface, simple socket, and we're going to pass a domain. Okay, so this constructor, when it's first called, we're going to give it initially these variables, and it's going to just pass all of those variables into simple socket. And simple socket is no longer going to actually call the function to do the connection. It has our virtual function here to connect to a network, but we're not actually calling it in the parent because it would try to call this virtual function, and that's not defined as anything yet. So now in the binding sockets constructor, that's where we're going to call connect to network. And we're going to pass it sock, and we don't have access. Okay, so we can pass it get sock, and we can pass it get address. Great. And we'll also probably want to do our check here. So we can call the function from the parent test connection, and we will do our test connection. Int will be the result of this. And we have a bit of a problem that I'm seeing in that connection is defined over here as a private member, and so I don't have access to it. So either I need to make that public or establish a setter function in the simple socket in order to use that. And this is sort of just the process of development. Yeah, I made something originally with an idea of how it would work, and then as I started adding on top of it, I started noticing that the actual way I'm going to use it doesn't reflect how I designed it. So I'm just going back and making some small changes. And none of these are going to require a dramatic overhaul of my simple socket class. It's just small tweaks to fix some problems that I was making. Anyway, we'll fix that in just a second. Actually, let's go ahead and fix that right now. So over in, let's make this a little more organized. That's going to be that. That's going to be that. And let's create a setter functions section. And we're going to say void set connection, and we'll pass it an int. And then over here we will void, let's set our comment. And all we're going to do here is say connection equals con. Easy. Okay. So we have that set, and I want to change something over here. Do you see how down here in this set connection, I just specify int, but in simple socket, I actually give names to these variables? I want to be consistent in how I do this. So I either want to put the name in there or I do not. And I like the way this looks better, but the idea of using headers is to separate the definition from the implementation. So when you look at the header file, you should be able to see like what the thing does, but you don't need to know how it does it. So, I mean, you're learning how it does it through this series of videos, which is fun and sort of defeats the purpose, but we're going to ignore that for a moment. The point of the header file is that someone who has not watched a long series on these videos can just look at a small piece of the code and see how it's supposed to work. They want to know how to use it. They don't want to know how it actually does what it does. And while I like the look of this, where I just say set connection, you pass it an integer, it can be better to say what the name is. That way they can tell what exactly, rather than just saying, okay, you're passing this an integer, it's better to tell them that they're passing it an integer representing that domain. So I'm going to go ahead and put names in here. The downside to this on my end is that I'm going to have to make sure that I'm consistent in the actual implementation files, but that's easy enough to do. Okay, so we have our setter function over here. So now we can come back to binding socket. And instead of saying int connection equals, we're going to say set connection and set it equal to the result of that. So now this function from the parent class is going to take as an argument the result of our connect to network function, which is going to be this binding implementation. And we are passing to that binding implementation the results of get sock and get address from the parent function. So we're really nesting our functions in one another here. And the last thing we need to do is fix this. So we're going to say get connection. Okay, so when we instantiate a binding socket object, we're going to pass it its domain, service, protocol, port, and interface. It's just going to pass those along to the constructor of simple socket. And then it is going to use the parent function set connection to set our connection variable in simple socket to be the result of what happens when we bind to the socket using the other private variables. And then we'll test the connection and again quit if something goes wrong. Now, is there anything else I need to add here? So I have connect to network, I have the binding socket, and let's take a minute to look at this just to check my work. Okay, so we're good to go here. And the question is going to be what to do next. Now, ultimately, my goal is to create a web server. And so I don't really need to do anything about this connect function. I'm not making a client at the moment, so building another object to do exactly the same thing that's done here as a client instance where it's connect instead of bind is a bit superfluous for my needs right now. And typically I would recommend building things as you need them. I don't really need a connecting socket right now. Should I ever need one, I can go ahead and build it then, and I would do everything that I did here. However, I have to take into account the fact that I'm doing this on YouTube. And to make a video where I do the binding socket and then I just start building the next part, which is going to be the actual web server aspect of it, doesn't make a whole lot of sense for a video title. So I'm going to go ahead and build the connecting socket. This only took a few minutes, so let's just go ahead and do it. So I'm going to create a new file. I'm going to put in a caveat that I will probably not always do this. This happened to be pretty short, so I have some extra time to work it out. So we're going to call it connecting socket. And, oh, it did not put them in alphabetical order. That's frustrating. Anyway, before we go on, let's add our comments in here. So we can say this is the constructor, and this is the and it's not an implementation, it is a definition. Okay. And let's say let's just say this is the... So there are two ways you can kind of use comments. One is in an algorithm where you're talking about what you were doing at some point. And the other way of doing it is by segmenting the code and making it look nice. So right now, it's obvious to me that this is the constructor. I don't need a comment to tell me that this is a constructor. but I'm putting it in there anyway just to kind of organize the code. You can think about it like this. If I write a paper for a class that I'm taking, and I write section headings for every single one of the sections, the first one is going to be introduction. Okay, I don't need a heading to tell me that this is the introduction. It's the first paragraph. It's obvious what it is. But we might still put it there anyway to have some consistency and to make it aesthetically pleasing. So even though it's not very informative, it serves some purpose like that. And that's what these comments are largely doing. And it's upset with me over here about something. What does it not like? I think the problem is that I don't need to specify that there. Okay. So the problem right there was that over here in my actual definition of the constructor, that's where I pass things along to its parent. Whereas in the, maybe this is a definition. I'm getting my words mixed up there. This is the implementation. This is the definition. So in my definition, I do not put the pass along to the parent class, whereas in the implementation, I do. Okay, so we've got that all set up, and let me write a quick description of this class. Hello, this is Eric from the future, and I come back to you now, having been bestowed with the gift of hindsight. So it turns out that watching me copy my class over from one window to the other, doing exactly the same thing, is not the most engaging content that you can put on YouTube. So in my attempt to have a consistent title, I actually made something that was somewhat boring to watch. So we are going to just do a brief time lapse here while I copy what I've already done. And in a second, I'm going to talk about typecasting in a little bit more detail. So I apologize for that, and in the future I will avoid making the same mistake. If you haven't seen this before, what I'm making here, this is called casting, and this is the way that you convert one variable type to another. You can do this with simpler things, like if you have an integer and you want it to be a float, you could cast it by saying something like, let's say int x equals 5, then I could say float x, but yeah, that's what it's doing here. It is converting this address to a struct sock addr, but it's making it a pointer. So this, the ampersand, is known as the dereferencing symbol, and that takes what is in a pointer and converts it to its actual value. So if you have a pointer at an address containing the number 5, and you use the dereferencing symbol on that pointer, you'll actually get the value 5 out of the pointer. So this is taking the value of what is stored and addressed and converting it to a struct of sock addr pointer. So it's a pointer to a memory location that holds this sort of struct and has the value of address in it. So anyway, and we'll say, not length of, but size of, and we'll say address. And what does it not like here? Return. I don't like that either. Okay, so you can see that by starting with this more generic class that is simple socket, I can then build more and more classes really easily that will have more and more specific use cases. So a simple socket is really any socket that you could possibly want to make. It just takes the function calls that you would already do in the C implementation, makes it in an object, so that all you have to do is say, hey, I want a socket object, and here are all the parameters I want, and it's going to do all of this work for you. And since I made it so generic, I can then come in later and say, I want a specific kind of socket that does it in this way. That is, I want it to bind to the network rather than just connect to the network. Or I can do connect instead of bind. So I have this tree of this really generic socket object that branches out into these two separate ones for a connecting socket and a binding socket. And then our binding socket in the next episode, we're going to create another subclass for that is going to be our server, where it's actually going to start listening to what's on the network and reply and do things like that. So until then, thank you for joining me. If you would like to keep up with the project, you can subscribe to the video. And as always, thank you for watching.